So as part of the training exercises we do, we have several worked assignments that you can go through and try to get the same expected results. We're looking at the oceanographic training document that now has worked assignments at the very end of the document. So assignment 1 is a subsurface mooring. So the idea is this gives you an example to work through and test the workflow and evaluation of the mooring parameters and so on. And it gives some results that you can check to see you get the same results from. So in this first part, this is a subsurface mooring, and the idea is to monitor the upper 500 meters of the water column. There's some constraints here, like using a Teledyne Long Ranger ADCP and a single float, as well as a starting wire rope size. It mentions a 44-inch ADCP float was used in a previous project and would be a good starting point, but to try and see what happens, and also, very importantly, keep the knockdown below 15 meters for data quality purposes. So let's get started with Oceanographic Designer. The first thing to note is it's 1500 meter water depth, and this is the current profile to use. So we'll change those parameters here. 1500 meters water depth. We'll also start adjusting the current profile speed. So at 0 meters depth, we have 0.8. And then we've got another data point here at 800 meters, 0.35. And then at 1500 meters, 0.025. That seems pretty much 0. So we'll put in the numbers there. Okay. Now, you could, if you want to, put it in full detail for the mooring design, but for really quickly scoping out a project and trying to get a sense of what components might be necessary, you can do something a little bit faster. So we under wire rope, we're adding a line, we're adding our 1/4-inch wire rope size. Now, this is going to need to be something like around 1,000 meters. We'll see why in a second. Let's have our ADCP buoy assembly at the very top. Now we need some flotation for this system, so you can do a quick search and search for 44 inches. Now I see that we'll need a subsurface buoy component because those are the ones that the ADCPs will slot into, and then and account for the wet weight of those ADCPs. No mention of depth rating. Maybe 750 meters would be okay. In reality, you may want to use something with a bit higher of a depth rating, just to be conservative. But this, in theory, this should be good because the depth rating is higher than the 500 meters it's supposed to sit at. So we'll select that, and we've also got to add the Teledyne Long Ranger ADCP. And remember, there's a quick search, so if you type in Ranger, that's the only thing with Ranger in the name there. That's the only option. So we'll select. Note the mass 86 kilograms, 55 kilogram wet weight. It's not nothing. So we'll pick that. Now flow opacity, this is how much drag essentially this adds to the system. The ADCP head pokes out a little bit. Usually for something sitting in the slot of a float, it should be maybe something like 10% as a sort of rule of thumb, because it's relatively well hidden inside the float. So we'll go OK. And let's now take a look at the estimated depth. That's really close to 500 meters, where we wanted it to sit in the water column. So we have to save this project. So we'll save project as. Make a new folder here. Subsurface A. Subsurface A mooring, just a folder to hold all the files. Okay, now we can export. And we'll go to static. That's all we need to do for this. It's generated our ProteusDS simulation toolbox files for running the analysis. So we'll just click on run. It should take a minute or so to run through the calculations. In solving the static profile, we'll get the vertical knockdown from this as well. And it's all done. So if you want, you don't have to, but if you want, you can take a quick look at it. Usually it's a good idea to just eyeball it for a second and see what it looks like. It's just loading the results in ProteusDS. I like orthographic view, engineering view. Let's just make sure we're looking at the east. And when we're looking with the camera views from the east, by default the current flow is going from the south to the north, so it'll move across this way. And there's the deflected mooring. So, you know, a bit of excursion there, and but that looks kind of more or less fine, but we really need to check what the vertical knockdown is. For this assignment, the constraint was 15, keep it under 15 meters knockdown. So we'll click on subsurface report template here, single leg mooring, quasi-static cable, and go generate. Let's view the report. So we've got all the parameters in here. We see the current characteristics are there. The loads are you know, well within a safety factor, but what I really want to look at is that knockdown values for the ADCP float. So we see 25, basically 25 meters, and you can see that's the expected result here at 25 meters with this 44-inch spherical float, initial depth of 500 meters. So we need to have something less than 25 meters. We need something less than 15 meters knockdown. So there's a couple things we can try. If we go back to our mooring design here, so we can close all these. Don't need them anymore. So we got one way to get around this is to use an X size up float. So I note that this 44-inch sphere is a deep water buoyancy sphere. And certainly they have much bigger spheres, 62-inch, and that will almost certainly do it. Let's just show what that process looks like. Is it optimal? Well, not necessarily, but let's just see what happens. So we'll just delete this old float. We don't need that anymore. We do have to make sure we have the long ranger in there. Workhorse long ranger, select. Let's just change the flow opacity there. Okay, good. Now everything's the same, still at, you know, basically a tiny bit around, under 500 meters, but it's pretty close. And again, we're looking at knockdown, which is a relative measurement. So let's run this analysis. So it's automatically made the same named folder. So the results are already still there from when we ran it before with the 44-inch. So we'll just go reset and run it again there. And it just takes a minute to go through the analysis. I'm not going to look at the results in ProteusDS, but let's just run subsurface quasi-static cable single leg mooring. Go generate, view, and we'll go all the way down to the knockdown. So we've got just a bit over 1 meter knockdown. Using the next size up, 62-inch has a knockdown of 1 meter. That's certainly way under what it needs to be. So here's where you might want to do a bit more optimization and just, well, is there something in between, or maybe we can look at you know, mooring systems, a 47-inch, different options here. Deep water buoyancy has 51-inch sphere. That could work. That could work as that would be something to try. I mean, you know, this is where you can do a bit of experimenting and kind of hone in on the size that might work well. But this is really important. You could try another alternative with 3/16 mooring systems wire. The braking strength is less, but you know, the loads are not really that great in the system, so you can try that. So you'd have to change this wire rope out. You could just make a different wire component and go through the same process. But yeah, see if you can get similar results and then experiment and see if you can get a better system working with a smaller float. So that's just what I want to show about how the general workflow for this assignment works. Thanks for watching.